Welcome to Mastering EE. Today we'll be looking at problem 10.3, which asks us to determine V naught in the circuit below. The first thing that I notice about the circuit that we want to have our attention to is the fact that our source voltage is in the sine wave form. So we want to convert this 16 sine 4t into a cosine function. Now, to convert any sine function into a cosine function, what we need to do is subtract 90 degrees. So that's exactly what we'll do here. We'll rewrite the 16, change the sine to cosine, leave the 4t as is, and simply subtract 90 degrees. Now, this is a lot easier for us to convert to polar, which is simply 16 with the angle of negative 90. Our next steps will simply be turning the capacitor and inductor into impedance variables. Let's start with the capacitor. 1 over 12 farads is going to be equal, or rather transform into 1 over j omega, which in this case is 4, times 1 over 12. Now with some simplification, we can get this down to 1 over j to the 1 over 3, which is just going to be equal to 3 over j, which is equal to negative j3. We'll keep this in mind. Next, we're going to turn the inductor into impedance variable as well. So we'll use the equation j omega, which again is 4, and the inductance this time, which is just 2. This simply turns into J8. Again, we'll keep this in mind. Now, to determine V naught, what we're going to want to do is do Kirchhoff's current law. So, KCL. And we're going to want to evaluate from this point. So we're going to do a little bit of nodal analysis. From here, we can say that our current moves, of course, from here. So it's going to move in a circular kind of direction here. Don't get this confused with mesh. We can say that the current is moving in a clockwise direction here. Now we could just call this, let's just say V1, and we can start doing our Kirchhoff's current law. So we want to take first our source. Source voltage will be 16 with the degrees of negative 90. And we want to determine between this point here and this point here. So we're going to subtract V1, and this is going to go over the resistor, 4 ohms, and also over the impedance of negative J3. And since the current down here is moving in a counterclockwise, this current will be most likely pushed up through this point. So we can add this source to this side as well, as we can assume it's going into the node. And that, of course, is just going to be 2 with degrees of 0. This will simply be equal to V1 over, I would say, makes sense to me that we are going from our ground state to up here. So this is just going to be our 6 plus J8. We can also add on this right side the resistance this way, as this is going out of the node. And that's just simply going to be V1 over 1, or we could just write V1. Now, how can we simplify this equation? Well, my first thought is to group all the V1s together and see what we can do from there. And for that, we could just simply take this V1, move it to the other side, and keep the polar on this side. So we could just have 16 degrees negative 90 over 4 minus J3 plus 2, 0 degrees is equal to V1. In fact, we'll just factor out the V1, do 1 over 6 plus J8 plus 1 plus our V1 from over here, which is just going to be 1 over 4 minus J3. So we're left with this equation, and what we want to do is solve for the node voltage. So the node voltage is of course V1, and to solve for V1 we'll just divide both sides by this variable. We can just assume that we know that, and we can write our final equation, which we can write in our calculator, which will be 16 degrees negative 90, not 16 degrees, 16 with an angle of negative 90 over 4 minus J3 plus 2, 0 degrees, all over 1 over 6 J8 plus 1 over 4 minus J3. And for those of you whose calculator does not like polar form, this will simply be equal to negative 16 I on the calculator, and then this will just be 2. So we'll box those off just in case you need those. So once you plug this into the calculator, I arrived at 3.14 minus 2.2 and then J. And doing a simple polar conversion, this is going to bring us to 3.836 with an angle of negative 35.025. And it keeps going. But this is good for our polar number. And from here, again, the question is asking us for V naught, and we've solved for V1. However, if we look back at the circuit, we notice that V1 is actually equal to V naught. this wire goes directly across the resistor. So the voltage at V1 is exactly the same voltage at V0. So we could say that V0 is equal to V1, which is equal to all of this. So, simply put, V0 is equal to the equation 3.8 cosine t minus 35 degrees. Now this is slightly simplified, but this is the answer. If you're interested in watching more videos on Chapter 10, they will be on screen now. Thanks for watching.